Hi, Ashna. I'm sorry, I couldn't hear everything you said. Can you repeat that?
Okay, I said we would begin the session by 8:35, but can you please share the first slide for now on your screen as a presenter?
Yes, sure.
The first slide has the info, right? That's an orientation session and it starts at 8:35, so the same slide. Yeah.
Here, if you can take a look and tell me if it's okay.
Yeah, it is okay. We are good. So let's just wait for a few more attendees to join in. Okay?
Sure, sure. Thank you.
Thank you. Hi team, welcome to DevOps orientation session. We are waiting for a few more attendees to join in, and as mentioned, the session will begin at 8:35 p.m. Pacific. Thank you, team. Thanks for joining in.
Learn. I think we can get started now. We were just waiting for a few more attendees to join us, but we'll get started and hopefully others will join in as we go. Um, as of now, I just want to make sure everyone can hear me okay and see my screen. If you can just put on chat, that would be appreciated. And we'll get started.
Shago, yes, we can hear you good and we can see your screen as well.
Okay, great. Thank you, Asna. All right, team. So welcome to the orientation session for our DevOps weekend batch. This is a beginner level training, and basically this is our first day for orientation, and we'll be holding another orientation. I guess day two next week. But wait for an email from IT Learn to confirm the time. So based on that, you can plan accordingly. So I just want to introduce myself first of all, briefly. Um, Once again, my name is Shagor Abed, and I come from a software engineering background. I worked on several projects, on the development side and on the QA side as well. And I have been working on a few QA projects with Varkasa, which is IT Learn's parent company, for the last few years. And even though I do my education, my bachelor's was in computer science in on the development side on programming. But I, got involved on the QA side, and with the direction QA is going nowadays, and the two worlds, will soon pretty much be working very closely, and they already are, and that's where DevOps come in basically. And as we go through the slides, we'll get to learn what DevOps is and what the importance is in the QA industry or just in the software engineering world, and how it's changing everything. So first of all, brief introduction about the course. This is as I said, it's a beginner level course. However, we will try to cover as much as possible to get you guys familiar with the process, the tools, and even basically get you close to as possible to become a DevOps engineer. So now this training is based on industry-driven DevOps training, which is intended to guide and prepare you to become a DevOps engineer through the introduction of DevOps methodology and several DevOps tools, as I mentioned, which is widely used in the market. Now, keep in mind, there are a lot of tools, but we will definitely focus on the ones that are more popular, the ones that is, what the employers are looking for when they're selecting their candidates. The primary focus is on building the proper foundation of DevOps to understand DevOps well and adapting to the industry demand of cloud deployment of applications through Maven, Jenkins, Git, GitHub, etc. Now, these are obviously some of the DevOps tools. You may have heard of them. You may even be familiar with some of them. But my intention is to make sense of everything, make connection with everything, and so you're much more prepared for a DevOps position in the near future. Now, prerequisites or eligibility for this course, there are no mandatory prerequisites. However, we expect that you have a fair idea of a software development process. Prior experience or knowledge in that area would be helpful. Software test automation knowledge or experience would be helpful as well. Also, basic Unix, Linux commands will definitely be a plus. Now, again, some of these things, you may need to spend some time on if you have not, spent time on these. But, things like basic coding or basic Unix commands, you can always, learn as we go. But other than that, ideal trainees for this course would be anyone who is a software automation tester or even have taken training in the software automation using Selenium or other automation tools. Developers who are looking into, I guess, get familiarized with the DevOps world, IT system admins, which, who deals with the operations side of the software engineering projects, and just basically whoever wants to get an excellent insight into the DevOps world and intensify their skills by familiarizing themselves with the best DevOps tools in the market today. Now, moving on, the topics that we'll be covering are briefly listed here. DevOps and Agile environment, and we'll go through that today. Server management, operating systems with Linux. I'm not sure if we're gonna get to that, but we'll definitely try to cover it as much as possible. Your scripting knowledge and how it's gonna play a factor. Version control with Git and GitHub, continuous integration and continuous deployment using Jenkins, GitHub, etc. Docker containerization with Docker. I don't know how much of it we'll be able to get used to, when it comes to Docker, but we'll definitely make an attempt. Automated monitoring Jenkins with jobs with Nagios. And this tool, some of the tools, you may have heard of them. If not, we'll definitely learn it as we go. Now, first question, these are the things we're going to cover today. What is DevOps? We're going to discuss the evolution of the DevOps process, understanding the model itself and how it works, QA role and expectations, DevOps tools, as I mentioned, and so on. So first thing, let's take a look. What is DevOps, right? Now, DevOps is basically, it's one of the components of a software development engineering test, meaning what's happening with the Q industry today is we are shifting towards a SDET model where QA is not just doing QA, QA work. A developer is not just doing developer work, and so on. And what I mean by that is basically when it comes to DevOps, what's happening is that the world between developer QA and the operation side, it's kind of coming together a little bit, and I'll explain why I say that. But before that, give me 1 second. All right, so now let's go to the next slide. And I'll first of all explain the model a little bit and explain what DevOps is. Now, we are all familiar with the Waterfall model. I'm assuming this is one of the software development model, which it's one of the traditional ones that we have been using. And basically, in the waterfall models, you have these certain steps that we have to go through, right? When we're developing an application, so you always have requirements gathering. You have to, find out what the functional requirements and specifications that we need in order to develop that application. And then from there, um, basically, we go through the design and analysis phase, and then eventually after that, the coding gets done by the developers, and then eventually, the testing has to take place by QA or user acceptance testing and all of that. And then after that, after all the testing phases has been done, the application or the product goes into deployment, right? So this is basically the waterfall model. Now, in this model, just keep in mind that all these steps here, they have to be completed before we can go to the next step. So requirements gathering have to be all completed. And once it is completed, we can go to the next phase and so on. Now, also in this model, one thing to keep in mind is if new requirements come into the picture while we're working on the application development, we're not able to implement new requirements because, in this model, this phase, this part has to be completed all the way before we can go to the next one. Now, when Agile model came into place, right? Um, whenever we have application production or application project development project in approach, with the agile approach, basically what's happening is in the agile environment, you don't have to complete this whole step before you go to the next phase, because in the agile model, everything gets completed as we go. So what I mean by that is, let's say if you have a dev team, right? And you have a QA team. So once the dev team takes care of certain things, right? And there's enough information for QA team to work with it, the QA team can get started on the testing part. So in this model, you can actually approach the project simultaneously. You don't have to wait for the BA team to finish all the requirements, and then the dev team will start working, complete all their coding, and then the QA team will start working. In this model, you can actually start working simultaneously, of course, given the fact that you have enough information to work with. Now, on top of that, in the agile model, requirements can come into the picture, in the middle of the project. So what I mean by that is, whenever you have a application development project, you have certain builds that come into the picture, right? Once the development team completes a certain build, it gets released basically for QA to test, and eventually it goes into the UAT environment, and eventually it gets deployed. Now, whenever we have a new requirement come in, then what happens is the dev team gets the requirement, and then eventually they start working on, with the design analysis, they implement the requirement and start coding on it again, and then eventually release it to QA again, and it gets tested and goes into deployment again. So in this model, requirements are frequent, right? So the main thing to take away from here is that in the agile model, requirement changes are allowed, and in this model, the releases are actually happening much more frequently, because you're not waiting for this whole thing to finish and then you do this and then you do this, right? You can continue in this direction. Whenever new requirements come in, you just come here, you take the new requirements, give it to the dev team, they work on it, and then go on. So now, as you can already realize, the development needs to be happening very fast, right? Because new requirements may come in, so you need to finish with what you have, and um, this has to be fast. And eventually, we'll try to deliver to the client as frequently as possible, as soon as possible, as efficiently as possible. That's the main goal of Agile. Now, in this model, we have operations as well, but the operation teams, right? What they work on is configuration management, and they deal with all the necessary servers that the application needs to be uploaded to, and all the tools that need to be configured and all of that, all the system requirements that needs to be met. So they take care of all of that. However, in this model, um, it's not so fast, right? Because what's happening is, let's say if developers complete a certain build and they release it to QA, and QA released it to UAT, and then eventually it went into deployment, right? Now, operation team, if they're not available here, right, we have to wait for them to get the product deployed and make sure all the configuration is done correctly and all of that. So that's where basically DevOps came in, right? And as the name suggests, DevOps is basically, it's a combination of process that developers do, and then also combined with some of the process that operation guys do, right? And what I mean by that, um, just like I mentioned, developers need to, work on the design of the code or design of the requirement plan, and then eventually do the actual coding. And then eventually the operations team have to, make sure the configuration is done properly, and that it gets deployed correctly into the right servers and into the right, right for the right I guess a crowd. And then eventually, what happens is they have to also check they have to monitor the the bugs. Like if there's any issue that comes out of the UA team, user acceptance testing, or if anything comes, if any bug is found after production, all of that they have to monitor it, and they have to make sure they report it back to the dev team, and eventually those things will be fixed, right? So now in the DevOps team, these two things, they're there. So basically, we still have requirements that can be brought in anytime, and requirements frequent, and basically developers also have to work fast, right? Because they have to try to deliver to the client as soon as possible. And then on top of that, in this model, what happens is the operation needs to be very fast also. And why that is possible is because if the developer or the QA is working in this approach, in the DevOps approach, basically they're familiar with the tools. They know what they have to do on their end in order to incorporate everything through this model, which makes the operation part much more efficient and much more fast. Now, as we go further, this will make more sense. But for now, all you have to remember, waterfall model is the traditional model where everything happens step by step, sequentially. And then when Agile came in, everything started happening a little bit more in parallel. It's happening much faster. And then DevOps model is basically trying to make this process much more efficient, much more faster. Now, give me 1 second. Let me go ahead and get this cleared up. All right, so if you guys have a good idea of that now we can move on to the next discussion, which is basically the life cycle of DevOps, right? Now, when we said DevOps life cycle, in addition to the agile environment, what we're looking for is we're looking for continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. Now, you guys already know about the development process, so there's no, what do you call it? Give me 1 second, sorry. Okay, so oops. Okay, so when I say continuous development, right? So as I mentioned, in the agile environment, the developers need to continuously work on developing any new requirements or new changes that come in, and they have to deliver to the client as soon as possible. So think about companies like Amazon, Facebook, Walmart, like big companies. They have to keep up with, I guess, user requests and any bugs that come in. They have to get those fixed right away. And they have a much stronger team that work in this fashion, in the DevOps fashion, where the development needs to be continuously happening, needs to be delivered, not only just daily, but even sometimes even several times a day. And this is because they have to make sure their process is very seamless, everything gets delivered on time, and there's no gap in between, or there's no user frustration from the user end. And so this needs to be happening all the time. As with the continuous development process, testing needs to be continuous as well, because once we once we develop the code, eventually that comes down to the QA team for them to retest or perform the regression testing once a certain module is done, and then eventually give the okay for the UAT testing, and eventually for the product to be deployed. So all of this is happening continuously. Now, next step is continuous integration. Now, when I say continuous integration, this is basically the heart of DevOps, where all of these things needs to be integrated together, right, in order to make sure it's ready for deployment. Now, when I say integrate, what do I mean, right? So once the development team finishes their code, they have delivered to the QA team to test, right? And then eventually the QA team has to, do all the validation, and they have to make sure everything is working properly. And they have to make sure they use the proper build tools to get those components ready. They have to integrate it for the operations side to work on the deployment. Now, as I mentioned before, the operation side is consists of two things, which is deployment and monitoring. And in the deployment side, what they work on is configuration management and containerization. And also on the monitoring side, they have to make sure that they check the system health, meaning the system performance, and also the performance of the product itself. And we'll go into that in a few minutes. But basically, just the overall product health check. And which is why this integration part is very important, because if it's not integrated continuously, it will not be ready for deployment, and eventually it will slow down the process, right? So having said that, let's take a look. Let's try to give me 1 second. Let's take a look, and let me see if we can, do a little diagram to make more sense of this. So give me 1 second. All right. So basically, what's happening? Let's try to get a good picture of that. So whenever you have an application development project, right, a software engineering project, now you have to do a few things. All right. Sorry. All right, so now what do you have to do? This is, let's say, software dev project, right? Now, here, what's happening is you have to first plan, right, what the requirements are. You have to come up with a plan, come up with a design, and this is all done, obviously by the dev team. And then what they have to do is they have to code, and eventually, after all this is done, once the coding is done, they send this information over to the QA team, or it's ready for the QA team. And what the QA team what they have to do is they have to, build build the project properly. They have to come up with some executable files, and eventually they will perform all the testing on it, right? Either it's integration testing or system testing, whatever the case is. But my point was, this is usually done by QA, and this is usually done by dev, right? And then what happens is, after QA team has created the proper builds, eventually they have performed all the testing of the code that was delivered by the dev team. Eventually what happens is, you have to um, do what's called integration, right? Now once you integrate all of this and you get it ready for the operations side, what happens then is, operations team, they go ahead and deploy the product. Of course, after checking on the configuration management and all of that. And then after deployment comes, well, actually it comes together with the operations tasks. So operations, or actually, let's go ahead and call this, let's just say operate. That's fine. Okay, so let's call this operate. And then eventually what happens is, as I mentioned before, they have to monitor it, right? Now, this is happening continuously. So this has to be continuous. This has to be continuous, right? This definitely has to be continuous, and all of it, so on. This is usually done by operation side, as I mentioned, and this has to be continuous as well. Now this is usually deployment, and this is monitor. Now here in this diagram here, you can see that without the integration part, we cannot move on to the next step. So it's very important that these things get done frequently and continuously, on time, efficiently, fast, and all of this play a major role. Now, moving on. Give me 1 second. All right, so let's go back to our slide really quick, and I'll show you. We'll go back to this for a second. And as I mentioned, that continuous deployment, continuous monitoring, all of these have to um, be done. Now let's talk about configuration management really quick, and then we can look at monitoring as well. So when we say, sorry, give me 1 second. Okay, so okay, let's talk about continuous development really quick. I think one other thing I wanted to mention is the tools that come into the picture in the diagram that we just worked on, right? So basically, my point is if in each of these steps here, right, there are certain tools that obviously, that are used in this process, and usually in this part here, which is planning and coding, tools like Git and tools like Jira, these tools are utilized, for source code management, version control, and all of that. And we'll go into that in our future session when I talk about version control. Those things play a major role here, and we'll get to see more of that. Now, when it comes to build and test, normally for build, tools like Maven is definitely is very popular. That is being used in the industry today. And when it comes to test, obviously Selenium, we have JUnit and TestNG. And these tools are what is being utilized in the DevOps model, as the popular tools. Of course, there are other tools that some companies may use. Integration, the most popular tool, the most in demand as of now is Jenkins, and this is something we'll definitely be focusing on. We'll spend a good amount of time understanding Jenkins and what its role in the whole DevOps process, and you guys will see that Jenkins does definitely play a major role. And here, when we're talking about deployment and operate, we're talking about tools like SaltStack, and there's I think there's Ansible. These are some of the tools that is being used. When it comes to monitor, we have as I mentioned before, Nagios and tools like Sensu. These are tools that are basically being used to monitor the product health, to see how how the final product is performing. And we'll go into that in a second when we talk about continuous development and monitoring. So now let's talk about continuous development really quick. So I'll go back to the other slide, and just really quick, what I wanted to mention is when it comes to continuous development. Uh, this phase, as I mentioned, it does involve planning and coding of the software applications functionality. And also another thing that I want to mention that I mentioned a little earlier is version control. And version control system, using a version control system when we're working with this is definitely definitely important, because you'll see that when different builds are released by the dev team, sometimes let's say you have an application that the dev team built, and they call it 1.0, right? And then let's say some new requirements came in, some changes came in, and they have to make changes. And then what happens then is basically, oops, sorry. Okay. Uh, all right. So whenever the dev team releases like the next version, which is let's say 1.1. So from 1.0 to 1.1, what happens is, let's say they have made the changes, and they have they have done unit testing on their end. They released it to the QA team. The product was tested. However, while testing, QA found that there's something not working properly in 1.1. For some reason, there's an error, compilation error, or there's something wrong in the business logic, whatever the case is, right? Something in the algorithm is not working properly. Now, what happens is, um, in order to get the product or keep the product up and running, they have to go back to the first version, which is 1.0, because 1.1 is obviously not a full working version yet. So they have to send that to the dev team to get that fixed, whatever the issue is. But in the meantime, they have to get 1.0. Now, if you don't have a version control system where you're keeping track of all these versions, and you're storing all these versions, meaning let's say the first time they wrote the code for 1.0, they should store it in the version control system, which is, for example, like Git or GitHub. Whenever they write the code for 1.1, they should also store that code. So just in case, if they have to go back to the previous version, they can use that. They can deploy the product with that until they fix the new version. Again, I don't want it to be too confusing, but we'll get to that when we talk about version control system. We'll definitely get a clear picture of this. Now, let's move on. Continuous testing, we definitely spoke about that. As continuous development is going on, testing needs to be done. And wait one second. All right, so after testing, integration needs to take place. We already discussed that. When it comes to continuous deployment, what I wanted to mention is basically what happens is applications functional requirements and performance needs to be checked here. So for example, let's say there's there's an application that has been deployed, right? Now, every application have certain specification, have certain expectation from the system itself. So let's say we need 4 gigs of RAM, we need certain amount of CPU power, we need some, certain amount of performance power from the system. So all of those things needs to be configured here, and that's part of part of our continuous deployment process, and the configuration management step in specific. And also a configuration management after configuration management is done, we also need to make sure that configuration, whichever we have decided for the application, is consistent on all the servers. So let's say the application is being released to, doesn't matter if it's 5 servers or 500 servers, the configuration needs to be the same on all the servers. And that consistency factor is important. And in addition to that, we also, in this step, we also need to make sure that we can schedule these updates and also releasing these deployments to the servers. So releasing, or actually, releasing the deployments to all these servers, and whenever there's an update to those deployments, to be able to schedule them, properly and release them automatically on the servers. That's also part of continuous deployment step. Now, also, in addition to this, what we have is, as I mentioned, containerization, and this is basically what it stands for. It's a set of tools which will maintain the consistency across all the environments. So let's say, the application is being tested on different environments, right? Now we have determined that certain tools, the application is working properly with certain tools. For example, Windows 10, for example, whatever, this amount of RAM, and this, this tool and this tool needs to be installed. Let's say I need certain version of Java, I need certain version of Flash, whatever the case is, right? So what we do, we create a set of tools, and I'll go ahead and write it down here. So basically what we do is, let me go ahead and get rid of this. Okay, give me 1 second. Let me just erase this. Okay, just bear with me for 1 moment. Okay. Okay, so what I was trying to say is containerization. What happens is, let's say you have tool 1, right? We need to install tool 1, tool 2, and tool 3, right? And we know, and when I said tools, I mean, like, it may be different applications, different things that we need in order for the application to run properly. So what we do, we create a set of these tools. Like, this is version, let's say tool 1.1. Let's say that the version of this tool is 2.5, right? And let's say this one works with 3.0. So what happens is, we take this different version of tools. We know our application is working well with this different sets of tools. And what we do, we group them together. We create a set of these tools, and the process of doing this is called containerization, right? And how does this help us? Basically, what happens is, when the product gets deployed, right? When we know that we have mentioned this set of tools, or we have specified, or we have found this set of tools to be working properly with the application, what happens is, then this same configuration could be used in order to make sure the application is working well on the user end, on the client's end, right? And one tool that is basically, actually, it's one of the first tools that has been used, is called Docker. And we will definitely get to Docker in our future session. And basically, we can see how Docker is used to to basically create this set of tools and manage them properly and efficiently. So yeah, we'll definitely get to that. All right, so now we have an idea of how we work on continuous deployment. Continuous monitoring is again done by Nagios, and we'll get to that later in the future session as well. But in the meantime, next thing we just wanted to basically touch base on is, give me 1 second. Okay, so basically we're going to finish up today, and next session what we're going to work on is what's called CI/CD, which is continuous integration, continuous deployment pipeline. Okay, this is basically called the CI/CD pipeline, and we'll go ahead and we'll take a look at the pipeline itself and exactly how what we spoke about today. We're gonna look at an example, and we're gonna see how everything comes into the picture, and we're gonna go through the process, in detail, step by step, and then it will start making more sense to you guys. In the meantime, what I want to do is just basically try to conclude what we just went over. So just give me 1 second, and oops, let me just open up a new page here. Oops. All right, so the takeaway here, as I mentioned before, you have the dev team, right? And obviously with any project you have a project manager, right? So there's a project management team, there's a dev team, and then eventually when dev team is done, it goes into operation team has to be in the picture in order to make sure the configuration part is done. And then of course we also have a QA team. So what happens here is whenever a dev team is done with the coding, so you have dev process, and then eventually what we have is called integration testing. When dev team is done, all the components have to be integrated. It has to go through a testing process, and then eventually there has to be a system testing, a complete testing for the whole application, and eventually after that you have UAT, right? User acceptance testing, and after that, what happens is it goes into production, right? So in the DevOps model, what I wanted to basically point out as a conclusion is this process needs to be done automatically. This process needs to be done automatically, continuously, right? And that's where the DevOps teams or the DevOps process come in. And basically, all of these things can be handled by any of these teams because everyone is following the DevOps process. So the QA has to, take care of a few things on their end and manage a few things on their end in order to contribute to the model. And then the dev team has to, do the same, and the operation has to do the same. So basically, when we look at the example tomorrow, we'll see, let's say if the dev team has, finished on a code, and basically they release the code to the QA team, and eventually, well, actually, they released it to the operations team, and the operations team found out that when it's going from, when it's being built, the executable file is being built, there's a compilation error, right? So whenever there's a compilation error, now in order to, instead of looking for the dev, whoever the developer is, or the dev team, let's say if they're not available, they're in a different time zone. What's happening is now the operations guy or the operations team is capable of taking care of that issue, and so they don't they no longer have to be dependent on the dev team. So this is something that we'll look at tomorrow, but other than that, I hope this makes a little sense of what the DevOps process is, basically what the importance of the DevOps process is in the software application development process. And basically all you have to just keep in mind is just an approach, just like an agile approach. This is just a step up. This is where everything needs to be more efficient. It needs to be happening faster, and that's where the QA will have to contribute, the dev team and the operations team have to contribute to the process, and eventually this is where the industry is headed now. And this is something, obviously I recommend everyone adding to their resume, because this is something that you will start to face in your future what do you call it, jobs, or future career advancements. So now, as far as the QA role expectations, we haven't gone into that yet, but tomorrow when we go to the diagram, we'll definitely specify what the QA is responsible for whenever the code is ready, or whenever the project is ready for the QA to test. We'll definitely take a look at that. But other than that, I think we have gone over all of this, briefly in details. So as of now, what I'll do is I'll go ahead and open up the floor for any questions you guys have, and then we can go ahead and take up your questions. And so if you have any questions, please go ahead and feel free to post it up in chat. We'll go ahead and try to get them answered for you guys. Okay, so I think Nitish might have had a question before. I'm not sure what the question is, but you guys, you can go ahead and post it on chat. Okay, so while we wait for Nitish's question, Rohit has a question. What are all the stages and process for continuous integration? Now, when we're talking about continuous integration, basically what we're talking about, let me go ahead and, one second, let me go ahead and open up this again. All right. Okay, so when we're talking about continuous integration, what we're talking about really is basically whenever the dev has, finished with their coding, they give it to, let's say the QA team, right? And when the QA team is basically has taken a look at the the what do you call it, sorry, when they have done with their testing process, right, what needs to be done is it needs to be built. It needs to be, basically what I mean by that is the project needs to be built into an executable file, right? And with the executable file, then the operations team that can work on the deployments part, and making sure all the configuration is figured out. And so basically in the integration process, what's happening is we're working on, getting these files created. So they're executable files. It can be executed automatically by the servers that is set up by the operations team. And so this is where you can schedule, for example, you can schedule. Well, I'll tell you 1 second. Okay, so what happens is, let's say Jenkins, right? So we have Jenkins, which is the tool that we use for the integration process. So what happens is, what Jenkins does, it checks the repository, right? Repository meaning like GitHub, right? Or Git. And what happens is, checks the repository at different times, So and I would say, yeah, let's just say different times. And what happens is, whenever it sees that a developer has submitted a code, meaning what we call it a check-in. So what happens is, whenever a dev checks in their code, a new version of the code, let's say a requirement came in and they worked on the code, and after they finished working on the code, it was checked into Git, right? It was checked into Git. And what's happening is Jenkins is looking for any new, any new check-ins that was submitted by the dev team. When it does find that check-in, it needs to use, it needs to take that code and build it, right? They need to build it and basically come up with an executable file, which again, like I said, that can be used in order to deploy the product by the operations team. Of course, like I said, configuration needs to be done and all of that, but the executable file needs to come out of this integration process. So that's what the integration part is. I hope that makes sense, Rohit. If you have further question, you can ask. And then in the meantime, I'll go ahead and get back to Nita's question. Nita says, could you relate to the container to the earlier diagram? I'm not sure which diagram you're talking about, Nitesh. Let's see. Okay, you displayed earlier. Okay, let me see. Give me 1 second. Another one version container. Okay. Okay, so I think you're talking about. Let's see. Let me see if I can go back to that one. Okay, were you talking about this one, Nitesh? Okay. Okay, Nitesh says, I got it. So I hope it makes sense. But basically, if you had a question about containerization, all we're doing is we're taking the different version of tools. So let's say I have Java, Java 9, right? Or Java 1.8, whatever it is. And then let's say I have to use, like I said, like Flash, certain version of Flash, right? 1.0, just an example. Let's say I also need, I also need Windows something, right? Well, I'm just saying. But what happens is when we know that we have tested our application with these tools and then it passed, right? It passed with this version of tools. What we do, we create a container that contains all these different versions of tool, and then eventually we call that containerization. And it's basically just a set of tools. We're just creating a set of tools with the specific versions. So I hope that makes sense. Okay, and let's see what else. So I really hope that makes sense. If not, please feel free to clarify or ask again. I will do my best to clarify. So in the meantime, I'll go ahead and go to the next question. Uh, oh, okay. So Nita, okay, before I get to the next question, Nita is saying yes, compared with software development project. Okay, so when we're talking about the software development project, so let's see here. I think it's better if we go to the PowerPoint and I'll explain where it fits in. So here, when we're talking about this part here, DevOps Lifecycle, right? So software development process, obviously goes through the development cycle, testing cycle, and then we get to the integration cycle. Even once the code is tested, it's been built, integrated properly, it goes into deployment, right? Now, when it goes into deployment, that's when we need to talk about containerization. Why we use containerization for this application is because we need to make sure we let the user know which version of Java they need to have installed on their system, what other tools they need on their system in order to run this application. So going back to my diagram, just basically all I'm saying is client Client needs to know what tools are necessary, or what what tools are necessary for the application. So basically what I'm saying is, when we use Dockers or other tools like Dockers to create a container and take this set of tools and use that, right, with configuration management, and what happens is the operations team then can talk about basically that you need this configuration. When it comes to your system, you need this much RAM, your CPU needs to be it needs to have this much power, need a processor that's this much faster, and then eventually they will also have to figure out what tools, here, let me go ahead and, so they need to talk about like what tools, uh, what tools that are needed in order to run the application properly. So all this is basically what I'm referring to, is basically you just need to know, like, how do I run the application properly on my system? In order to run it, what do I need? My system needs to have what type of specification, what other tools do I need? Java, do I need Flash? So all of that, that's what containerization mean. I hope that makes sense when it comes to, I guess, when we're making it, when we're talking about it in the software development project. I hope that makes sense, Nitish. Okay, and okay, all right, good. So we'll be receiving the invitation. Yes, you'll be receiving the invitation for the next session, with the links, of course. And then, in the next session, like I said, I'll go through the diagram and it will start making more sense, because we'll go ahead and take it one step at a time and see exactly how automatic deployment and automatic, monitoring comes into the picture, and the integration, all of that. So we're going to talk about all these different steps, and we're going to go ahead and take a real life example, and then we'll discuss that. Okay. All right. And now next session, there was a session scheduled for tomorrow. However, there might be a change. So please go ahead and wait for IT Learn to send you an email. If you want, you can check. You can try to log in tomorrow the same time. And if you're not successful, I mean, if the time changes, go to webinar. We'll tell you when the next session is. But also, just keep an eye on the email from IT Learn. So if not tomorrow, I think the next session will be on the 5th of July, US time, which is 11:30 p.m. I think India time it's 6th of July, 9:05 p.m. But I could be wrong. Just wait for the confirmation email to go from there. Okay. All right. So one question I wanted to address, I think Avishek had a question. How can I shift my career from QA to DevOps? Okay. So, and then it says, what are the prerequisites a QA should know before entering this field? Okay, that's a good question, Avishek. So going back to when we talked about the eligibility of the prerequisites for DevOps, you need to have certain knowledge of how the software development process works, right? So, let's say we're talking about this waterfall model. If you know how this works, you need to have a basic idea. Hopefully from this session it makes sense. If not, you can always, get an idea by looking at our other videos for QA process, what do you call it, our QA training, or automation automation training, and you can get a good idea of the different models. But obviously you have to have an idea of how the software development project works, what the steps are. Of course, we're going to cover it here, but it would help if you have an idea. If you have some experience, or if you have training in software test automation, meaning you have taken your training in Selenium, or you have prior experiences with Selenium, that will be even better. But along with that, knowing some basic Unix commands, you can definitely keep up with the topics here. So it's nothing. No prerequisites here are mandatory. It's nothing that you can learn as you go. Obviously, if you're completely brand new to QA, you may have to put a little bit more effort in. But other than that, I think it's something, anyone can pick up and continue our journey together. So I'll try to make it as, step by step. I'll make it as easy to follow as possible for you guys. And, obviously we can work with each other to make sure we're all on the same page. And that's why we have this Q&A session. So you guys are always welcome to ask questions, and we can definitely get you moving in the right direction. Okay, so I hope that makes sense. And as you saw, from my presentation, testers, developers, IT system admins, they're all in the picture, because this is the operation team, development team, and the QA team. So whichever side you're working on, or whichever side you want to end up on, DevOps will definitely benefit you in the future. And this is something that is, that a lot of employers are looking at nowadays, and this is where the industry is going. And I think a lot of you agree. Nitish also says this is, industry-wise recognized. So yes, I do agree. So this is something that you definitely want to add to your resume. Right now, it is popular. It is being implemented. A lot of job requirements are looking for QA testers that are familiar with the DevOps process, with the DevOps tools. And in the future sessions, after our next session, we'll get right into the tools. We'll get to learn how to work with Maven, Jenkins, GitHub, Docker if possible. So, it's definitely going to be a very informative session, training, and then we'll definitely get you guys ready as much as possible for the DevOps side of the project, okay, or the DevOps industry. All right, so I hope this was a good session. I hope you guys were able to get some good information out of this. If you have, any question, or you want to review some of these materials we went over, you can always review this video. The links will be sent to you guys, and it's also available on our website. If you go under, I'm not sure exactly where it's going to be located, but I think you'll be shared a link from IT Learn. So please do look out for that. And if you have any questions, please, you can bring it to the next session. We can take a look at it. But I think it's good enough for today. Just wanted to show you guys what DevOps is, why is it important, why is it in demand, and the answer is basically everybody is trying to become more efficient. Companies are looking to have people that are more prepared. They're not just doing one thing. They can also work on the dev side, work on the operation side, and this is all part of like a SDET model, like I said, SDET role, because DevOps are just working with different programming languages like Java, R, C Sharp, Python, like these things they are looking for from QA testers, because it makes their life a lot easier. It makes the DevOps process come into the picture. Okay, and all right, so Nitish has another question. Name of the certification that can be taken. I'm not sure if there is a certification. I can look into that, Nitish. I personally have not looked into it, but I'll definitely take a look at it, research that, and get back to you. In the meantime, if you guys can find any certification that candidates can look at, do share with us on the next session. But I'll get back to you on that. Okay. All right. And if you guys have any other questions, we can definitely take up those questions. Let's take a look. All right. Okay, Nitish says need to drop off. Okay, thank you, Nitish. Have a good day. Thank you. Good night, good day, wherever you are. All right, so guys, any other questions? Okay, I don't see any more questions. So, Ashna, I think we can end the session for today, and we can let the participants know when the next session is going to be. Okay, you're welcome, Artana. Thank you all for joining. And I'm looking forward to seeing you guys in the next session. We'll get a much better idea of this DevOps process, the CI/CD pipeline, and exactly how things need to happen step by step, precisely on time, and all these things will come to the picture. All these tools will be addressed. All the different roles will be addressed from the different team. So this will be something you guys should definitely look forward to on our next session. Ashna, are you there? If you're there, we can end the session. I don't see any other questions from the attendees. Okay, guys. So since there are no more questions, thank you guys for joining. We'll see you guys in the next session. Have a good day. Have a good night wherever you are. Thank you once again. Uh, I'll see you guys in the next session.